Okay, so now let's look at this kind of intimidating looking op amp and see if we can figure out what we're doing here. And we're supposed to be finding the value of VO. So the first thing that we'll want to do to make this look like all our other op amps is to change this current source to a voltage source. So we're going to do a source transformation on this. So to change a current source with a parallel resistor into a voltage source and a series resistor, the voltage is going to be the product of these. So 2 milli times 2 kilo, a milli and a kilo cancel each other out. So I'll have plus 4 volts, with the plus going up because the arrow's going up on our current source. The resistor doesn't change, so that's still 2 kilo ohms. And then we've got the rest of our op amp circuit. Okay, so I'll label these. That's 4 kilo ohms, 6 kilo ohms, and 6 kilo ohms. Okay, so we know that, and just write it every time. You know, you might get points for it even if you get nothing else. VP equals VN, and IP equals IN equals 0. Well, in this instance, we see that VP equals 5, and so we know that VN also equals 5. So what we're going to do here is my favorite type of circuit analysis technique. I love, we called it node voltage. I think y'all call it nodal analysis. And so that's what we're going to do. And I'll call this V1. And this is Vn. And I'm going to write node equations for those. Let's see here. V out is here. So V1, I'm going to start going this direction. V1 minus 4 over 2 kilo ohms. I'm going to make sure I watch my work here. Plus, now going in this direction, V1 minus 5, because we know Vn is 5, over 6 kilo ohms. Plus, now this, all of this is at V out. So plus V1 minus V out over 4 kilo ohms has to equal 0. And now I'll do the Vn node, but I'll just call it 5 because I know it's 5. So 5 minus V1 over 6 kilo ohms plus 5 minus V out, this is going up, over 6 kilo ohms equals 0. Alright, so now I can cancel out all the kilos, so multiply each equation by 1,000 on both sides, and then I'll multiply this top equation by 12, and I get 6V1 minus 24 plus 2v1 minus 10 plus 3v1 minus 3vo equals 0. And I'll multiply this bottom one by 6. So I get 5 minus v1 plus 5 minus vo equals 0. So from the top one, I get 11v1 minus 3vo equals 34. I always make lots of mistakes on these, so y'all keep an eye on me. Even looking at like my solutions, I make mistakes. Minus v1 minus vo equals minus 10. Or let's just change that to v1 plus vo equals 10. Okay. So 11 minus 3 equals 34. 1 plus 1 equals 10. And I get that V1 equaled 4.57, but I don't think I was looking for that. V out is 5.43. And the problem said find V out. So V out equals 5.43 volts. And sound like a broken record if you've heard me before, but I really like that calculator. It's the TI 36X Pro. It does all kinds of good stuff. Okay, so questions on this one?